Good evening. Today we are going to learn about sorting. Sorting means arranging the elements in ascending order. There are several sorting techniques: bubble sort, selection sort, insertion sort, quick sort, merge sort, heap sort. For any sorting, after completion of sorting, we are placing all elements in a ascending order. Today we will discuss about bubble sort. In bubble sort, first you compare the two adjacent elements. If one of the left is greater than the right element, we have to swap. Otherwise, you have to move right. Move one position to the right. Repeat all these steps. If there are n elements, it requires n into n minus 1 by 2 comparisons. For example, see this animation. It explains the working of a bubble sort. If there are 5 elements, in that 5 elements, in order to sort these 5 elements, it requires 4 comparisons, 4 iterations and 10 comparisons. See here, in first iteration, A of 0 is compared with A of 1. If A of 0 is greater than A of 1, so we have to swap these 2 elements. Then A of 1 is compared with A of 2. In this case, A of 2 is greater than A of 1, so no need to swap. Then A of 2 is compared with A of 3. A of 2 is less than A of 3, so we have to swap these 2 elements. Then A of 3 is compared with A of 4. A of 3 is greater than A of 4, so we have to place A of 3 at A of 4. After completion of first iteration, we can place the max element at last. In second iteration, we have to swap the elements up to 0 to 3 only. In this iteration, we will get the second most maximum element at last. Like this. In third iteration, we will get the third greatest element in that particular second position. So if there are 5 elements, it requires only 4 iterations. After completion, that it requires 4 iterations and 10 number of comparisons. After completion of the sort, we will get all the data in ascending order. In order to solve this problem, we open the editor. In the Dev C++, it is an advanced editor. In this particular editor, open a new file. Now write a C program to sort n elements using bubble sort. Include io.h. It supports printf and scanf. Int main. Then you have to declare an array of size 20. Then n is a size of the array. Then we take one variable, I is a loop variable. Then printf, enter size of array. Size of the array. Then scanf %d, ampersand n. Then printf, enter %d elements, n. Then write a loop for I is equal to 0, I less than n, I plus plus, I less than n, I plus plus. Read the n element. Scanf %d, ampersand a of I. Then we can print the elements. Print elements before sorting. Then you have to print the elements. Then you have to write a loop. Then printf /n or otherwise %d/t %d/t comma e of I. Then after that we have to write the logic for restriction. For I equal to 0, I less than n, I plus plus, we repeat the loop. Then for each and every time for j is equal to 0, j less than n minus I minus 1, j plus plus, if e of j is greater than e of j plus 1. We are comparing adjacent element. E of j is greater than aj. We have to swap the elements. T is equal to e of j. E of j is equal to e of j plus 1. E of j plus 1 is equal to t. Then print the element after sort. Element before sorting, elements after sorting. Then save the file, sort.c. Then declare a variable t, compile a file. Now j is also has to be declared here. Compile the file. Now 0 compiled is compiled successfully. Then we have to block that one because avast is there, so how to block the avast for disable for 10 minutes time. Yes, then run the program. 5 elements, 3 4 2 7 1. Before sorting, after sorting, then select all, enter, copy output here, start. We are storing the output also. So then save the file. You will get the program. First you are reading the size of the array, then we are reading the elements before sorting, then we are writing a logic, then after sorting we are printing the elements, then our output. So thank you for watching.